So we're going to continue our notes for Chapter 3. This time we're in Section 3.2, which is Measures of Dispersion. Now, what the heck is dispersion? Well, dispersion is a fancy way of saying how spread out something is. The more dispersed it is, the more spread out it is, right? I mean, can you imagine, I don't know, take a handful of marbles, you drop them on the floor and they go scattering all over the place, right? Well, if we're mathematicians, what we want is a number that will measure how scattered they are, if you will. And we're going to find a whole bunch of them, but the most important one is going to be standard deviation for us. All right, so we're going to start off with just a little talk about what dispersion is. So dispersion is how spread out it is. And I have here a data set. To order food at McDonald's, one must choose from multiple lines, while at Wendy's, one enters a single line. The following data represent the wait time in minutes in line for a simple random sample of 30 customers at each restaurant during lunch hour. So there's the 30 wait times for Wendy's. There's the 30 wait times for McDonald's. Oopsie. I did not mean to do that. There we go. All right. So the sample means for each group are below. What do you notice? They're basically the same. Wendy's and McDonald's. Cool. Right? 1.39 minutes for both of them. But here are the histograms. Right? So that's the actual picture of the wait times. Now what do you notice? Well, they had the same center, right? The balance point is 1.39, which is here. Let me pause and put the arrow in there. Remember, the mean is a balance point, so it has the same balance point for both of them, same mean of 1.39. So the same balance point, but the McDonald's data wait times are more spread out, right? These are smeared more to the left and right than these. These are all kind of clumped around that center. All right, cool. So what we want mathematically is we want a number that'll measure that for us. Like, we can see it visually, but you're not always given a picture. So we want a number for it. Now, the first number we're going to come across is called the range. Now, the range is the largest data value minus your smallest data value. Now, some books will actually just say, like, your range is 2 to 19, and some will give it as a number, 17. Our book uses this, right, 17. So that's what you're going to do. So you're going to find the range for both Wendy's and McDonald's wait times. All right, so for Wendy's, it's the max for Wendy's minus the min, right? Now, the max for that particular restaurant is 3.99. You can go back a page and look at it. And the min was 0.35, which means our range is, 3.64. Boom. All right. Okay, what about the range for McDonald's? And again, that would be the max minus the min, highest value minus the lowest value, which is equal to 4.54, take away 0, which is 4.54. So there's the range for that one. Boom. Done. There was no need for even Excel on this particular one because, I mean, all you had to do was look for the highest and lowest values. That said, we're going to learn how to find it with Excel in just another minute or so. But there we go. Right, so which restaurant had the more spread out times? Sure enough, McDonald's is more spread out. Because it has the larger range. All right, hold on, let me bold this. There we go. That makes it easier to read. All right, now I have the following are a sample of scores from 2 classes. Find the mean and range for each data set. Well, my friends, this is going to be a put into Excel kind of thing. So let me go back to our handy dandy Excel spreadsheet. And I had 3.1 example 1 right there, 3.1 example 3. I'm going to click on a new sheet and type 3.2 example 3. Oops, see if I could spell the word example. There we go. And I'm going to paste these in here. But of course, you probably won't have them available in that format, so you're going to have to type them in longhand. Sorry about that. Someday I will get on top of it all and actually have this available. Oopsie. As a, hold on. Actually, I want you to see what I'm doing because it's kind of a cool little thing. So if ever you're stuck in, like, for example, this table's in a row format. I don't really want a row format. I want a column format. So if you click on Paste Special, right-click on Paste Special, and over here, it's Transpose, and I click that, and there we go. And then I've got that same data set, but in column format instead of row format, which kind of makes me happy. All right. Now we're going to find the mean, I think, and the range. I'm just kind of cleaning up my spreadsheet here. And I'm going to zoom in to make it easier for you to see. Okay, find the mean and the range for the data set. Okay, so I'm going to label these. Matter of fact, I'm going to insert a new column here, just for the heck of it. Mean, range. Now the mean, remember we learned how to find before, it's equal to the average of this data set. Oopsie. Boom. And the range is equal to, now, to do this, you can do this a couple ways, but I think the easiest way to be max, parentheses, of that data, close your parentheses, minus the min. I'm going to let you figure out what max and min mean. And I'm done with this whole scrolling thing. So B2 colon B11. There we go. Enter. And then what you can do, besides bold all this, since I figured it out with using cell references, what I can do is drag it to the right. Oops, I better show you how I'm doing that. So I highlight these little guys right here, move your cursor down to the bottom right corner so it turns into a plus sign, and drag it to the right, and there you go. It figured it out perfectly. And no, it's not a mistake. Look, click up here. It's figuring it out for these same data sets. It's just that Alana was very crafty when she came up with these data sets. All right. So I'm going to make these colored just so that they're easy to follow. Beautiful. Fabulous. It was driving me nuts having no border on that left side. So there we go. All right, so I can go back here. Matter of fact, I can copy and paste these. Copy, go back here. I found the mean and the range. There you go. So the mean and the range for algebra and for stats is both 74 and 40. This is algebra. This was stats. All right, now let's look at a dot plot of that same data. What do you notice? Well, we found that they had the same range and the same mean, right? But are they really the same? So even though the data sets have the same center and range, they are very different from each other. Right? The stats exams scores are much more spread out. Right? Because it's not just a question of whether the lowest and the highest. See, lowest and highest is 40 apart for both of them, like Alana picked it on purpose, right? But look at these algebra scores. Other than that, they're all packed in here around the mean. The mean, remember, is 74. So let me put that shape in there just so you can see it. So the mean is right here. Boom. Right, so there's the balance point for both data sets, but look at the stats exams. They're all over the place, right? You got a whole group down here in the 60s, and you got this group up here in the 70s, then that guy at the 80s, and so on, right? So what conclusion can we reach about the range? Okay, well, the range is very simple to find, but it is not a good measure of spread. Oopsie, I could spell. Of a data set. Okay? Probably because it's so simple to be fine, to be honest. Right? So it's not doing a very good job of measuring spread for us. It just tells us the highest to the lowest. Difference between the highest and lowest, but doesn't give a sense of what's happening in the interior. Does that make sense? Okay. All right. We've done range. We've found out how to find it, and we will move on from there next time to talk about the variance and standard deviation. See you then.